the Hamburg process would end up with an effluent quality, if I can find it, that looks very similar to this one. Not bad looking, but it will not nitrify. It will not anywhere get near meeting your year-round nitrification requirements, nor will it meet the 0.1 phosphorus. So it is a good wastewater treatment option, but not for Grand Bend to meet the type of effluent quality that's been determined is required. Let's look at the blue frog and see where it fits into here. If you look at the first, second, third, fourth, fifth box down, it says biological oxidation. One of the things that's required in biological oxidation is the supply of oxygen. The blue frog is a small-scale oxygen supply system that would perhaps fit in that point as a small component of biological oxidation. It is not a system that treats wastewater and produces a high-quality effluent. It is an aerator that sits on top of an oxidation tank and provides some oxygen. So it also is not an option to replace the orbital system that was suggested by your consultant. Most of the things that have been thrown up in the air as options approach red herrings. All the viable options have been looked at by one of the most credible engineering firms in Canada. Almost $1 million has been spent looking at these options, and they have been reported in the EA document. I would suggest that you all read the EA document. It's an excellent document. I'd like to give you an analogy. A farmer runs 1,000 acres, and he decides that he's doing contract work for his neighbors. He wants to expand his operation. He needs a new tractor. He goes out and looks at all the options. He decides that he needs a 175 horsepower tractor to replace his old unreliable one and to allow him to meet the obligations he has with respect to his neighbor's contracts. His neighbor across the road comes to him and says, you know, I've got this Farm All H. That's a great tractor. It's been around since the 40s, and it is just as reliable as you can get. And it's a lot cheaper than that thing you're looking at. I think you should buy one of these. His brother-in-law says, you know, I was down at Home Depot, and I saw a great tractor. It was less than $2,000. What are you spending $170,000 for? And it comes with a free mower. His bank manager, on the other hand, says, what are you spending money for? Get a dozen hoes and put some people to work, provide employment. They all may be good options for some parts of tilling soil, but it doesn't meet his requirement. And that's what's been happening with your considerations of wastewater treatment in Grand Bend. All these red herrings have been thrown out on the table, and you voted down the tractor. And go on. The whole issue of servicing the areas of Zone 3 and Zone 4. Let's review what the MOE said. Chris Hutt said, and I quote, these are all quotes. I went through Chris Hutt's presentation. I listened to it. Thank you very much for recording it. It was most helpful. Septic systems are not the answer in sand or clay. He said, failing septics in sand cannot be seen. So doing an inspection, you aren't going to see it's failing. You can't look at concentrations. You need to look at loadings. What did he mean by that? What does that mean? It means that you can stick a well into the ground and pump some water out, and it doesn't matter what the concentrations are. We aren't looking at drinking water here. We're looking at the impact on the lake. And the lake only knows how many pounds, how many tons of nitrate are you putting into the lake every year. It doesn't care what concentration it comes in. If you were drinking it, it's a concentration issue. We aren't looking at contamination of groundwater because of drinking. Next one, sorry. If I could stop this, I would. Well, my time's up, you're right. And I put the timer on. Okay. And then he says, what the loadings that you are putting in are in fact impacting the lake water quality. I told you that the Healthy Lake Huron and the federal government are both looking at changing sewage effluent requirements in the near future. Any future development cannot take place without adequate sewage treatment. And the provincial and the federal monies are available now, but they may not be available in the future. If you wait any longer, they may not be available, is exactly what he said. Next. I gave you two other papers. One by the U.S. Geological Service, paper 3, and one by the Penn State University. In paper 3, if you look at the, on page 4 of 8. Oh, sorry, first look at page 2. It gives you a graph. Figure 2 says nitrate loadings in thousands of pounds of nitrogen per year and versus the year. Well,
Jerry, slow down.
Page 2. See? Of the third article I gave you. It shows that for 9,300 homes, they were going to put in 145,000 pounds of nitrate coming out of the septic systems. If you downgrade that to the number of homes in zones 3 and 4, we would be putting in 90,000 pounds per year. If you look at the next page, there's a little note there, right in the middle of the page, that says, sandy soils allow rapid infiltration of septic system effluent to the water table. If you look at the page 4 of 8, it gives some great examples of nitrate contamination of groundwater. These are related to drinking water. These are related to drinking water, and the numbers get close to drinking water numbers. That is not the case in Grand Bend. They don't get anywhere near the drinking water levels. The purpose of providing that paper is to show that the nitrate moves with the groundwater. The same on the next paper. The next paper gives you some great examples of what's happening when you put septic effluent into groundwater and how it moves. It then talks about a mass balance approach. If you take the numbers in this paper, you will find that you can calculate for 1,900 septic systems 180,000 pounds per year. So you can see the range. There's quite a range there. I would say probably 120,000 is probably a reasonable number to expect to see going down into the lake coming out of zones 3 and 4. You have any idea what 120,000 pounds of ammonium nitrate fertilizer looks like? Well, the picture down the lower right is a picture of about 120,000 tons. If it's too deep, those bags are 1-ton bags. You're seeing about 60 bags there. If you think it's a good idea to put that much nitrogen fertilizer into the lake every year, continue to do what you're doing. Chris Hutt said, it's time to fix a mistake we made 40 years ago. We'll provide a lot of the money to do it. It's up to you to vote for it. Next, please. You wonder why you don't get a lot of nitrate levels in those samples you're taking. Well, we arbitrarily stuck 12 holes into the ground. If you look at this drawing that comes out of paper 4, which is done by the University of Waterloo, they show you how these septic plumes flow in the groundwater. They mix very little with the groundwater. They still stay relatively defined. They put in something like 50 samples immediately downstream of a septic tank that had been there for 40 years, and half of those samples showed no contamination at all because the plume was so well defined and stayed so well defined